testing. Okay. All right. All of you are here. So, shall we continue on the exercise? Take a look. My screen. This is one. Yeah. Can you see that one? We are now having question 18. Okay, question 18. 17. You tried it yesterday. Can you see Can you see it? Yeah. Okay. So 18. So in today's lesson, we would like to go over with you the remaining questions on chapter 36. And if time allows, we may go back to the calculations mode, which is on chapter 38. I know some of you may have got difficulty in that part. Now, 18. Now we have got the potassium peroxide disulfate. Can you please see that one? The one you find it in your book, page 29. Take a look, page 29. So potassium peroxide disulfate, what is that? Do you know what is that chemical? Let me see. How come they? Oh, wait for me. How come my pen doesn't work well? Yeah. Do you know what's that? Peroxide disulfate. It is a type of a very strong oxidizing agent. A very strong oxidizing agent, S2 with the formula S2OH2 minus. So it can oxidize, here comes example, iodide to form sulfate and iodine. And the instrument to be used to monitor the reaction is calorimeter. Okay, calorimeter was used to follow the change in concentration of iodine. The absorbance will be measured and will convert to iodine concentration. So explain why calorimeter could be used in experiment. As the reaction process will happen. Say yes, we have got a color change. Well, the color change is due to what? As the reaction proceeds, the reaction mixture changes from colorless to brown gradually. So related to the equation, to the book, so you may find it is due to what? Due to formation of brown I2 AQ. Okay, so the concentration of iodine increased throughout the whole process. So you know that the darkness of the brown solution will become increased. So, and it is done by what? It is used to measure the absorbance, right? Absorbance is used to measure indirectly the concentration of iodine, because iodine, it is brown. It's brown. Can you get the point? Okay, so this is what I would like you guys to know. Iodine, brown iodine, concentration of iodine will increase throughout the progress of reaction, while you use the colorimeter is used to to measure the absorbance. Okay, to measure the color intensity of the brown solution. Okay, B, suggest how the initial rate of formation of iodine can be determined in a concentration time graph. So you get once you get this, you may get the idea what is that concentration time graph. So what is that? Concentration of iodine, concentration of iodine versus time. So what would we expect? Will be a curve like this. So the question is how you from this graph how you can get the initial rates. First of all, draw something. Draw a line. Draw a line where? And what will you call it? Tangent. Okay. Tangent. At where? Where will we draw the tangent? Initial rate at time is equal to hello 鄭群威講陳景熙 where
等一等啊。
B you don't have any. I will mean my initial rate. You are going to
即係一開始嗰條斜線就延伸咁畫上去咯，即係唔需要連住嗰條曲線，咁就係 initial rate。
So what is that line? What do you call it?
Tangent.
Tangent, yes. At where? What time? At where? Time is equal to
0.
Yep, 0. Whereas time is equal to 0, and then determine its slope. So you are going to draw the tangent. So this is the way we draw a tangent. Okay, a straight line at time is equal to 0. Got it? You got it? 張家榮 late. Now 19. You get it, right? So 19. Sodium thiosulfate solution reacts slowly with dilute HCl to form a precipitate. The chemical kinetics of the experiment can be studied using blah, 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 right? So it takes for what? The small fixed amount of precipitate to form under different conditions. So you know what is that precipitate? 張家榮, you know what that? What is that? What is that precipitate? What is it? So if you know it, it may help you write down the equation. What is that? So a very authentic equation that you need to draw. What is that? You need to write, what is that? Forgot. Sodium thiosulfate. How to remember this one? Na2S2O3 AQ plus hydrochloric acid HCl to form what will the product? Now I would request you guys to memorize this one well for that equation. This is NaCl and then SO2. The precipitate, what's that? It is colloidal sulfur. And finally, water. So you are going to balance that equation. So we have got 2 Na, right? So you have the 2 here, and that's it. Okay, so this is the equation for the reaction of thiosulfate react with HCl. So the ionic equation is S2O3 2 minus plus 2 hydrogen ion to form SO2 and H2O together with sulfur. Okay, so this is what you should know. You are expected to memorize this one well. Okay, anyone who have memorized this equation, please put up your hand, or maybe you just put me a tick. No, you ought to, right? You ought to memorize this one. So identify the product of this reaction which formed the precipitate. What's that? You may know it is easy, right? It's sulfur. the sulfur precipitate, which will mask the Macross experiment, right? So in this experiment, we are not going to do Macross. We need to check the turbidity. So you may see that, right? How would you measure the time taken for the small fixed amount of precipitate to form? Draw a label diagram of the experiment setup you will use. 19C. If you anyone who can draw the Macross experiment, what is that? For those who can draw it, could you please put up a hand? You know how to draw Macross experiment. Take across. You know it, please put a tick. Otherwise, across. Simply across. Just for all of you. How about the others? Yeah. And then? And then? That's it. So where to observe? Where to observe? Yeah, here. So you better draw an eye here, right? Your eye is here. You're going to observe that reaction mixture. Well, the reaction mixture found inside, what is that? What is that? What is the chemicals you have to tell? Right? It is the sodium thiosulfate solution. Thio means sulfur, okay? Sodium thiosulfate solution. Together, now if you can manage, right, you are going to add the HCl as well, and you are going to look through it vertically. And the cross we have got, it seems that we have got a solution just placed above the Macross. The Macross, it can be made on a piece of paper, or you use a permanent marker, or maybe the water-soluble marker, and mark it on a white tile. Okay, can you get my point? You get it? So we've got a Macross on a piece of paper or white tile. It is also possible. So you may have this, and you may start the reaction like this. Okay, is that clear? Is that clear? So this is C part. How about D? The turbidity means what? Cloudiness. How cloudy it is. Of the reaction mixture increases when the reaction proceeds. The amount of light can be passed through the reaction mixture. We will call that a light transmittance will become less. Okay, so which means less light can pass through this solution when it is turbid, which is cloudy. The more cloudy it is, the less light can pass through, such that the light sensor will detect less light. Okay, so this is the general principle. So you are going to connect the light sensor towards the data logger and try to see what will happen. The question comes, give one advantage of using a data logger with a light sensor. So should you still remember our table yesterday? That maybe give you some clues, some of the wordings that you may use. So what is the advantage of using the data logger with a light sensor? This time connected to computer, right? So what can you get? 房家豪, what will you get? No? Marcus?
The readings for one can be taken very rapidly, and they're much more accurate than other forms of measurement.
other forms of measurement. We will have got the data logger, right? So data logger, if you want to talk about rapidly, some of you said rapidly, and it's not just the word rapidly. It seems like real time, right? Real time measurements. So and at the same time, the data can be collected continuously. So it is quite different from quenching. Right? For example, some chemical method, just like quenching. The quenching experiment, you just do some sampling only. So we cannot get the continuous data. So if you have got continuous reading, or even if your computer can manage, you can make it into graph, turn the data into the graph. You can do such data recording automatically. So this is what I would like to measure with you. This is about the term continuous measurements. Okay, continuous measurements of the light transmittance can be made. Is that clear? So which wins over the other way of doing the measurement, just like quenching, right? Quenching, you know, that is continuous versus discontinuous. The second thing maybe if you have got a meter to directly measure the light transmittance, the burden will be go back to the human, right? Because for the human, we cannot get continuous data so easily. You just look at it and then copy, look at it and copy, and at the same time you look at the timer. So it will cause much inconvenience. So if you want to take a continuous reading, continuous data, you better use the data logger, and it will give you an easier life. Questions? Questions? Easy? Yeah. So question 20. Question 20, you talk about the reaction between the fizzy drink tablet while I put it into water, right? So you know that fizzy tablet will have got two chemicals which will cause effervescence. So one of them it is said it is sodium hydrogen carbonate. The other one, you know what's that? You forgot? Yes, a solid acid. What is that acid? In fizzy tablet. Normally, what acid it is?乜叫藍？乜叫藍？ Where are you? Oh, not here. 黃俊豪 Carbonic acid. Come on. Ascorbic acid. A little bit, right? But most of them, it is not just ascorbic acid, you know, vitamin C, right? So citric acid is just more, right? It is more than ascorbic acid. So that's why if you have fizzy tablet, normally it is of lemon or orange flavor. You can get the meaning, right? Because citric acid, you mix with that fizzy filling, it will already give you a smell just like lemon or citrus fruit. So we call it citric acid. Okay, so this is the reaction, and you are going to monitor the change in mass over time. The change in mass over time. Of course, carbon dioxide leave out from the reaction mixture, the system, such that they will make the total mass drop, right? So this is the diagram like this. Do you know what's that? Do you know what's that? You know what's that? So in Form 1, you may be taught about this symbol. You know what's that? Yeah? So what is the use? What is the use? Well, you know that what here in that area, we do not have any data. But for the mass of the conical flask and the reaction content, right? So you may have a very slight change. in mass in a certain data, range of data. So I want to magnify this part only. But if you use the real number scale, you may find that this graph, right? This graph, the shape of the graph it seems like a straight line only, okay? Because most of them is just space, okay? It's just compress this graph into a line like this. So you will find it quite difficult to get to know what is meant by the rate of reaction. Can you get my point? So what you're going to do is to just magnify that part to see, and such that you will see the change. Question A. Explain why effervescence occurs. Wow, come on. It is not the question about rate of reaction. It is acid alkali, right? That chapter. So what is that? The first tablet contains, except before, contains what? Contains a solid acid and mainly citric acid and sodium hydrogen carbonate. When dissolved in water, so what will happen? Some keywords. Too early to say so. Too early to say so. You are going to tell it step by step. When dissolving water that's solid acid, what will happen to it? What makes effervescence? You know, a reaction, right? Reaction between hydrogen carbonate ion and what? You know the reaction. And yes, ionize. You need to have that term, ionizes, to give hydrogen ion. And because of that, right, so the hydrogen ions, what do? They react with what? With sodium hydrogen carbonate, or in particular, once I dissolve in water, the whole thing, right? This one also dissolve water. So you're going to talk about it in particular. It is hydrogen carbonate ion to give carbon dioxide gas. So that's why that is effervescence. Okay, so the equation, it is like this. The simplified equation will be this, right? Hydrogen carbonate react with hydrochloric acid to form carbon dioxide and water. Do you still remember? Yeah, do you still remember this one? Forgot? Chen Longwang, you still remember? And Chen Ji, you still remember? Hi. Yeah. How about this? The mass of sodium hydrogen carbonate in first tablet drink was 1.25 gram. What is the mass of carbon dioxide given off? Yes, forced to say yes. You cannot say no. B, can you, for this type of reaction, it gives a assumption, right? It gives an assumption to make full use of that 1.25 gram of hydrogen carbonate to react to form CO2. So what is the assumption? This one is limiting, right? This one is limiting, otherwise you cannot calculate. So according to the equation, what we will get? It is in 1-to-1 ratio, okay, to form CO2. So if you are going to project this to these two, what you're going to do is to find out the number of moles of CO2, which is equal to number of moles of hydrogen carbonate. Now, so what is that? Hydrogen carbonate, you are going to calculate as mass over molar mass. So the hydrogen carbonate, it is what? NaHCO3, remember? The whole thing, not just hydrogen carbonate. Sodium hydrogen carbonate. So what is that? The molar mass, it is 84.0 gram per mole. So we'll get 0.0149 mole. So you use this to calculate the mass. So the mass of CO2, it is what? 0.0149 mole times its molar mass, 44.0 gram per mole. So what will be the answer? It is 0.656 gram. Can you manage to do this? Yeah. Okay. So if the question changes a little bit, okay, if the question changes a little bit, like this, right? You know that you besides using data to monitor the change in mass over time, okay, I can also use gas syringe to measure the volume of CO2 over time, right? Tell me, you know my question is, right? Tell me the volume of CO2 to be produced based on this data. I changed the question a little bit. This time, I'm not asking you the mass of CO2. I change it. I want to ask you the volume of CO2. So what is that? How to calculate? Use this, right? Use this to continue. How? Volume of CO2 gas, it is equal to what? Number of moles times what is 24.0 dm cube per mole. What is that? We call that molar volume, right, of CO2. So it is 0.0149 mole times 24.0 dm cube per mole. You know how to answer. You know how to calculate this one, right? Afterwards, what will you get? What will you get? It is the questions evolving as a dm cube, but not cm cube, right? 0.0149 times 24. So you may get it as 0.358 dm cube. So you change it to cm cube, remember to times 1,000. 358 cm cube. Okay? You get it? How many of you think that you can manage to do the red one? Okay? Could you please put a thumbs up? Let me know. No, if not, otherwise, you know, your thumbs will be pointing downward, right? You don't know how to do just down. You know how to do up. Just 5, 6. How about the others? 陳景希、張家榮 You know how to do it? Now, could you please let me know by showing me the sign? And 陳志軒、蕭俊熙 You don't know? 蔡仲常、麥耀南 Marcus, you don't know how to do. but you just write down and 300 something correctly. Pujihin, you know what is that about? The calculations of mole ratio. Here comes a new formula. Number of moles times molar volume of a gas to form the volume, to get to know the volume of a gas. So while the term 24.0 dm cube per mole is universal, right, for all gases at room temperature and pressure. C part. What is the advantage of using data logger in this experiment? Again, continuous measurement, right? Any more point? You may think of continuous measurement. And also you may find that this time we really take care of accuracy, high accuracy of monitoring the reaction. Why? Do you know why? Because the change in mass in this case is very little. It's very little. So if you use the data logger, we look for accuracy. Yes, real-time measurement, continuous measurement, so acceptable. So main advantages for real-time measurements. Second, and that is actually very useful because those change in mass should be carefully seen, and the apparatus should be, the equipment should be very, very sensitive. Okay, up to 3 decimal place. You know what to do now? Yeah? Yes or no? Pu Jian, are you really here? Hi, Pu Jian. I'm now checking who just opened the device right without listening to it. 麥耀南。
喺度，阿 Sir 係咪叫我？
Yeah, I just want to double check. Who are just idling, or you just open the device and then go away. Xiu Junhei is another guy.
喺度啊，做咩啊 Sir？唔係啊，我冇掛機㗎。
Okay. I don't know. Question 21. Question 21. It is something like essay type question. Outline a tetrametric method that could be used to measure the change in concentration of compound A with time. Compound A is an alkaline, while compound B, C, and D, and they are neutral. A is alkaline. So you may guess what I want, right? So what are the major steps? First of all, you know that, right? While you mix A and B and start the time. Start stopwatch, right? Start recording the time, right? And what is the next step? Zhang Gaowing, are you here? Hi, Zhang Gaowing. Oh, I realized another guy who just opened the device and leave and just left. Huh. Quench, before quench, you mean you are going to quench the whole solution, the whole batch of the solution? No, just a few. Your first, before quenching, you're going to take what? Take samples, please. Take small samples. Yes, of known amount, a known volume. So you use pipette, yes, at regular time interval. So you are going to do that action quite frequently, okay? Or let's say minutes, maybe 5 minutes for per 5 minutes interval, get this. And 3, quench it. How to quench? Cooling in ice, or maybe by adding large amounts of iced cold water. So if you write down the second statement, which means you are going to do cooling and dilution, and this will rapidly slow down the reaction in the reaction mixture. How about the 4? Do the titration, right? Titrate each sample against what? Against standard exit. So I don't normally I use HCl. Normally I use HCl. Questions? Questions? Hello. Now I just want to double check if all those are there, and if not, I'll not treat you as a presence. Also, once again, Zhang Gaowing, are you here? How about the exit catalyst? Well, you may also quench the solution mixture by destroying with acid catalyst. You may. How? Just remove it. Not just delete. It's not computer, right? It's not computer file, right? You cannot just delete. How? So it really depends on the acid catalyst. No, not really high temperature. I don't know whether or not the catalyst is. I don't know whether or not is it an enzyme. So if you just like a simple exit, so you are going to do something like, for example, react with hydrogen carbonate and you can quench. I don't know. So I cannot answer your questions about this. If it's enzyme, also you may use some chemical method. Okay, for example, I add some chemical to deactivate the function of enzyme, or maybe a high temperature is just one of example by which we deal with denature the enzyme. But nothing stated about the nature of catalyst X. I don't know whether or not it is enzyme. I don't know. Not stated. Now it seems that some of you would like to have a further consolidation of the calculations of mole ratio, when you talk about the volume of gas, right? Volume of gas. So could you please refer to chapter 38? Finally, take a look. Chapter 38. So in this this week, we just go over with you that 2 chapters. Chapter 38. Take a look. You find it. So shall we take a look? Recall your memory about this. This one it is of using the 2 formula. It is volume over molar volume. Here comes mole. Now, so we have got several formula. Now, just recall your memory. For those who just come here and you feel not comfortable, we have got several equations to be used. First of all, if you're having the number of moles here of a gas times Avogadro's constant, what will you get? Let's see, what is that? We've got number, right? Number of gas particles. So in particular, if you want to go, you know that gas, most of them they are molecules, right? So you are going to talk about molecules. Second, if you have got a number of moles of gas times molar mass, what will you get? What will you get? 喂，張家榮 are you here? Oh, still not here. Yes, you may get mass of gas. So just check the units and you will know it is gas, right? It's in forms of gas. And how about this? Volume of 1 mole of gas is called what? Molar volume. How do you know that molar, right? Because I mark it as 1 mole. So you know what's that? Used together, molar volume times molar and number of moles of gas. Yes, here comes volume. That's right. Volume of gas can be calculated. Okay? You know what to do? Yeah. So, I would like you guys to try it out and question 19. I don't know whether or not you still remember what is that? Question 19. Double thumbs up here. You will see that questions. The traditional gunpowder, do you see that? It's a mixture of potassium nitrate, sulfur powder, charcoal powder. When this gunpowder is ignited, the reaction occurred can be represented by the equation below. The sample of gunpowder was prepared by using the following quantities. Calculate the total volume of gas at room temperature pressure produced from the explosion of this mixture at room temperature and pressure. So what does mean by that? The gaseous product is sorry, N2NCO2. You are going to calculate that too. Okay, N2NCO2. Total to get to know total volume of gas. So to start with, what is the first step? You are going to have that free. So what you're going to do is to find out what number of moles of those quantities. So can you find out what is that? First of all, 8.00 over what? Potassium nitrate. Yes, limiting reagent. 101.1 gram per mole. Here comes 0.0971 mole. Similarly for carbon, so you may get over 12 to form what? About 0.0311 mole. And 1 gram of sulfur, the molar mass is 30. Oh, sorry, it is sulfur. I confused that too. It is 33.1 and 8.1. So 32.1 and 12. It's a 0.0833, and this one is a 0.0311. So what will you get? So what is that? So you may get that too. Any idea about the term limiting or in excess? Which one is limiting? Which one is in excess? carbon is limiting. So if you have got the carbon is being a limiting reagent, carbon is limiting. That means 0.0833 mole. This one. Okay. So what is the next step? You use this to project the number of moles of N2 and CO2 respectively. Agree? The limiting, the carbon is limiting. Now, if you compare with carbon and sulfur, you know 3:1 mole ratio divided by 3 is just 0.02 something, right? So you know that the sulfur will, not all sulfur will be reacted. How about KNO3 also cannot be fully reacted, right? So use this 0.0833 mole. How you project that to? 3 mole to form 4 mole of gas. Is it correct? Yes? Okay. So you try to add it together. All together we've got 4 moles. 4 moles of gas. Can you get my point? 3 moles of C to form 4 moles of gas. So what is the total number of moles of gas? Remember that 3 to 4. So it is 0.0833 over 3 times 4. Agree? What is the answer? For the mole, number of moles. 0.0833 divided by 3 times 4. 0.111 mole. You get it? And the volume of gases produced. So remember, the gases here means N2 and CO2 together. So you are going to calculate volume, right? So don't worry. You can get mix of that. So we'll get 0.111 mole times 24.0 dm cube per mole. So what will we get? 2.67 dm cube. Okay, so the main point is that this one, first of all, you are going to get this is a limiting reagent, while the other two is in excess. So it is done by calculations. You may check the mole ratio one by one, and you can get this idea. Okay, so you may find that not all KNO3, potassium nitrate, and sulfur will be reacted. Just part of them will be reacted. So if you are going to consume all carbon, right, you have got the phenomenon. So you know carbon being limiting. So you use this to project the number of moles of gas to be formed. Because we have got 3 moles of carbon reacts to give 1 mole of N2 and 3 mole of CO2, which means 4 mole of gases. So you may get just make the all together and make it times 4. And because of the fact that according to Avogadro's law, the number of moles of any gas particles will be reflected in their volume. So irrespective of nature of the gas. So you can try to use this data to calculate as a batch and times the molar volume of a gas to form the volume, the total volume of the gases produced. Okay, is that clear? So here comes 2.67 dm cube. Questions? Now that means, do you want to have more practice of this type tonight for mocap? It seems some of you got puzzled. Anyone who want to have more practice on that? Now could you please put a tick? Anyone who would like to have more practice on this type? So be prepared that we will have a quiz right after this lesson on chapter 33 first. And then I will schedule a quiz on calculation of volume of gas later. All of you are okay? Just 3. 3 for chapter 36 or 38. For both chapters, or just 38? What do you mean, Susan Hay? You mean 36 or 38? 38. So you know my reply. Practice makes perfect. Yeah, practice makes perfect. So we will continue on doing this tonight. Okay, see you.